Welcome to the Accenture Innovation Center in Essen. Today we would like to show you how unfortunately easy it is to attack a legacy control system with an example here of a utilities grid and how we can monitor if such attacks happen and try to prevent that these cause bigger damages in the network. For this we have here an entire electric grid set up here, starting with some elements about building automation in the building, then the generation as such, so power generation for the windmill, and then the part that we will focus on today is the electric substations, so basically the gigantic switches that control where the energy is flowing to, and we have two complete sets here of all the control systems that are typically seen in such a substation. And we have also here in the end a large number of different routers, firewalls, and monitoring systems that you typically see in an utilities company, starting with the SCADA systems to the office network where the people are working in the back office. The attack scenario that we want to show you today is based on this innocent USB stick. Assume that I'm a SCADA technician and I have the task to update in a local substation the local software of the SCADA system. And I'm under time pressure, I have to drive there, I cannot do it remotely, I need to be on site directly with access to the equipment to do this. And I got this USB stick with the latest software and the instructions from the SCADA vendor. I am at the server cabinet in the substation and I now want to install the update. So I use the USB stick in here. In our environment here, we have a complete monitoring of all devices and all the servers in the network. So we get immediately a warning that there has been a USB flash drive inserted in that desktop here that runs the SCADA system. So we could immediately contact the local site and see what's going on. However, in most cases, it wouldn't be monitored, so the technician would go ahead in the control room to install the new software. So I'm now on the SCADA system directly, so that's the software side of the device where we plugged in the USB stick. And everything looks fine. So I go to this USB stick, and the first thing I want to do is I want to check the installation from Spraycon, which is here the vendor, with the installation instructions. Strange, it doesn't open. Our security system has identified that an unknown process has started on the SCADA system, and it immediately sounds an alarm in the cybersecurity control room. However, again, we assumed here in this example that the local SCADA technician is not aware of that. Probably they don't have such a system installed, so he would just continue with his investigation, what's now going wrong. From a SCADA control screen display perspective, everything looks fine. Everything is green. All the switches are closed, so the energy should be flowing. But probably the technician can already see or hear from a phone call that there has been a power outage in one of the areas. So I can try to manually check here again if the switch here has a problem. Oh, it says the status here should be open, but it says the local status is closed. Well, okay, that's strange. It doesn't change the status anymore. I think we should have a closer look and directly check at the cabinet, directly at the switch control system. So I'm now directly at the device controlling the switch, so deciding which circuit should be open and which one should be closed. And I can see here, unlike to what we've seen at the ABB control screen, is that the first major switch is actually not closed. So this means there's no power flowing through. I need to manually update this now. I can do this here. So I can say now, okay, please close that switch. And it does that. So everything looks fine. But a few seconds later, it suddenly switches off again. So there must be something interfering here with the control network. And it seems that the display in the control room, on the control screen, and the actual control here in the cabinet do not sync anymore. So something is wrong here. This was a very simple example for an attack, but it's not an unrealistic one. You probably have read about such incidents where malware was distributed over USB sticks in control environments already before. In our case here, the control room has lost the complete control over the control systems. So they cannot trust the screen anymore. And it seems also that this process is constantly overwriting any command that I'm doing and simply switching off the switch every few seconds. So this is not simply a loss of control, it's even a danger for the grid, because it would mean that a large number of power consumers are switched on and switched off all the time, which could cause an imbalance in the network. In our Accenture Innovation Center, we have the latest IoT cybersecurity sensors installed. So they are both installed on the SCADA servers themselves, so on the software, and they monitor the entire data traffic within the SCADA network. So we constantly monitor anything that's going on. If there's a new behavior that has never happened before, it would immediately sound an alarm. This, again, would have not prevented the attack in this example, because with the USB stick, the software was installed locally and it then spread locally. The benefit of having the monitoring here could have been that we could have intervened earlier. We could have stopped or at least initiated a review, sending someone there if suddenly we see that a USB stick is inserted into a critical device, and probably we don't know that this is going to happen. Also, we have then the warning that suddenly a new process on this SCADA system has been appearing, and we could have then immediately also acted, called the local substation, or at least isolate the network immediately of that local station. In the end, it still is required that you then act locally and remediate the issue on site and remove, in our case, the virus that has been installed, and then constantly sending SCADA commands that are changing here the programming of the control switches that we have here. The entire monitoring is not really a bastion against attacks. It helps you to react quicker, to identify the issue faster, and isolate the problem within your big grid and make sure that it's not spreading across the entire company. Thank you so much for watching this video. If you are interested to learn more, we welcome you to the Essen Innovation Center of Accenture in the Zeche Zollverein in Essen in Germany. The description with the contact details can be found below.